Hopefully for tonight, it's only 4 problems. And we're looking at definitions. In your own words, define zero pairs or the additive numbers property. In your own words, define the identity property of addition. Number 3, represent a zero pair using tiles and describe it in your own words. And number 4, represent negative 7 plus 12 using tiles and zero pairs. Describe your number in your own words. 4 simple problems. Like I said, this week is going to continue on like this so we can get ready for next week. Yay. So finish copying that and then we'll continue. So right before I get started with the objective, look up to the screen, writing utensils down. So I'm going to do a recap of what you guys saw in the video that I assigned the other day. Okay? So watch. Same situation, very similar, but it's the same property at work. So watch. If I was to give you the situation, and it says, if I dig a hole that's 7 feet deep, how much dirt do I need to cover the hole? So here it goes. So here's ground zero. Here's me, muscles and all. There it is. And I'm going to dig a hole that's 7 feet deep. There it is. It's 7 feet. So if I dig 7 feet out, guess what I'm going to have here? 7 feet of dirt. That is correct. Now let me show you as to why each one is labeled what it's labeled. Question. Is there any dirt here? No. You answered no. What kind of answer is that? No. Negative. That's why this becomes a negative 7. That is correct. Question. Is there any dirt up here? Yes. And what kind of word is yes? It's a positive. Therefore, negative 7 and positive 7, that equals to 0. And that's pretty much what you saw in the video. Is that correct? And that's what we're going to be elaborating today a little bit more. Okay. However, to get started, here's the objective, and it reads, I can define and represent integers using integer tiles and zero pairs. Let's read together. 1, 2, 3. I can define and represent integers using integer tiles and zero pairs. Now look at the question here. Look up. Look at this question. What is the concept for today? Before you say it out loud, just think about it. What is the concept for today? Look at the objective and tell your neighbor what the concept for today is. Now, for some of you that still haven't figured it out, here it goes. Look up to the screen. What color is this question? Green. Therefore, my concept for today is integers and zero pairs. Does that make sense? And what are we doing with those concepts? We are what? Defining and representing. So copy your objective at the bottom left of your Cornell note, please. Do that right now. All right, so for today, I'm going to focus on integers. So what do I do with that concept? In your Freyer model, this is the Freyer model, you're going to write what in here? Integers. What are integers? Integers are whole numbers including their opposites. 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 Can you hear the definition of integers? Integers are whole numbers including their opposites. Oh. So you guys already know this, right? So I'm going to show you some examples, but I need to clarify the definition before I show you examples, okay? All right, here we go. So I'm going to go ahead and define integers. Look up to the screen, please. Writing utensils down. Focus, please. So since we are going to be dealing with a lot of concepts in this class for algebra, I want to make sure that you understand definitions before you move on to do anything with concepts. Now, in the past, they just gave you definitions. You memorized the definition, and then you did stuff that they asked you to do. But I need you guys to understand the concept as we're moving on. So for today's going to be like a simple one but I want to make sure that you see how we can break down the definition. So look up to the definition. It says integers. Integers are whole numbers including their opposites. Well, first, before I define integers, I see a word here, whole numbers, that some of you might not be clear as to what whole numbers are. Before I give you integers, I need to define whole numbers. What are whole numbers? Whole numbers are counting numbers including 0. Let me repeat that again. Counting numbers including 0. Okay, so let me take you back to preschool. In preschool, they sent you out to have recess, and then you run to the swings, right? Trying to beat everybody to the swing. And all of a sudden, you tell the person next to you, "I'm going to race you," right? And what do? I'll count it off. Ready? -1, negative. No, we don't start counting with negative. We start counting with what? 1, 2, and 3. Well, guess what? Counting numbers are 1, 2, 3, all the way to infinity. Don't copy this yet. You're just paying attention. Writing utensils down. However, I said whole numbers are counting numbers including what? 0. Now these are whole numbers. These entirely are whole numbers. So now that we know what whole numbers are, counting numbers including 0, now I can define integers. Let's see what the definition says. Integers are whole numbers. Are these whole numbers? Yes. But now it says including what? So what am I missing here to make it integers? -1, -2, -3, ... all the way to negative infinity. All these are integers. Question, is 12 an integer?
Yes.
Is 155 an integer?
Yes.
How about -28?
Yes.
How about -267?
Yes.
All those are integers. So copy that, please. All right. Now that we know the definition for integers and what they look like, now let me give you a non-example so that you don't confuse them with what I'm about to show you. Once again, these are integers. What I'm going to show you over here are not integers. You understand what I'm saying? Okay, so here we go. Writing utensils down, look up to the screen. We'll finish copying in a little bit. Okay? These over here are not integers. Let me zoom in. Look at those. These are not integers. So, before you copy, think about this question. If these are integers, why are these not integers? Talk it over with your neighbor, please. Why are these not integers? Okay? And I'll take volunteers in a little bit, but for right now, copy copy the none examples. Copy none examples, please. Do that right now. Okay, I'm going to zoom out. Okay, so we have integers, and these are not integers. So, volunteer, why were these not integers? Yes, over here. They're not whole numbers, and they're... Okay, close. He said these are not integers because they're not whole numbers, and they're
not counting numbers.
Okay, counting numbers are included in whole numbers. So they said they are not whole numbers, and they're, everyone, opposites. That is correct. However, if you wanted to put it in simple words for somebody that's looking at these, why are these not integers? Look at it. Because these are what? These are decimals and fractions. That is correct. That's the simplest way that we can put it. Okay. Now, what goes here in the critical attributes? Look up, please. Here, we're going to do this. Let's say I asked you to get your phones out, and I asked you to take a picture of this, and then you're going to snap it or Instagram it or kick it or whatever it is you use. to your people, and you're going to send them a hashtag as to what integers are. Think about it. What would you hashtag integers are? Yes. Hashtag what? Whole numbers. Write that down. Whole numbers. What else? Another hashtag. Hashtag what? Yes. Hashtag opposites. So now check this out. I want some hashtags to clarify what integers are, but when you look at this, what would be a hashtag that can include this idea here in a hashtag? Hashtag what? Yes. Integers are fractions? What would you hashtag it then? Yeah.
Hashtag non-whole numbers.
Integers are whole numbers. Yes. Hashtag no fractions. No fractions. And the last hashtag. Yeah. Hashtag no decimals. So look at these 4 hashtags. Let's see if that clarifies what integers are. Are they whole numbers?
Yeah.
Are there opposites?
Yeah.
No fractions, no decimals. Yeah, so that's what critical attributes are, what makes the concept. Everybody understand? All right, now that we're done with our Freire model, now I want us to start with a property. Underneath here, the Freire model, you have some lines, right? On the first line, write this property down. Let me go to that. Write that down, additive inverse property, right underneath your Freire model. From there, you're going to skip 4 lines, 1, 2, 3, 4, and on the 5th line, I want you to write this example. Ready for the example? Okay, here it goes. On the 5th line, you're going to write a plus negative a equals 0. Next one, underneath that, you're going to write 7 plus negative 7 equals 0. Underneath that, you're going to write negative 15 plus 15 equals 0. And underneath that, 0 equals negative 2,500 plus 2,500. Okay. Now, in the past, most of your time was spent like doing computation, doing some geometry and statistics, stuff like that. But it was mainly computation and some concepts for you to see, like how some figures, areas, and perimeters, right? For this year, I want you to start thinking by yourself in regards to what would be a definition that you can do for certain things that I show you. So for today, look at this. These are 4 examples of the property additive inverse at work. So this is the additive inverse property at work. Put your mathematician hat on. If I was to ask you to write a book, what would be a sentence or a definition that you would have for the additive inverse property? Think about it first. Look at it. There it is working. What would be a definition for the additive inverse property? Talk it over to your neighbor, please. What is the definition for additive inverse property? All right, let's see. Now, mind you, it has to be a structured sentence. So imagine that if you were to turn this into your language arts teacher, it needs to be structured, right? Okay, who can get us started with a sentence? Yes. Okay, hold on. Just like that, or the additive inverse property? Okay. The additive, write this down. Where on the 4 lines that you skip, right? The additive inverse property. You said is? Yeah. Is what?
An integer or a number.
Okay, hold on. You want me to start with an integer or a number?
Integer.
Okay, so Yes, these are integers, but let me ask the question just to clarify. Can I do this? This is not true? You have 3/4. Take away 3/4. What is that? So is it still working? Yes. Okay. So then with that, now that I clarified that, now that I clarified that, what do I write here? Let me repeat that again. The additive inverse property is, yeah, okay, a number and its opposite, what? Equal to 0. And see if you agree with that definition. Yeah, right? Makes sense? Okay. Next, I'm going to give you one more definition. Write it right underneath here where you did the last example. You're going to write the next definition or the next property. Oh, and by the way, what are these known as? What did I say in the video? They're 0 pairs. Okay, just to clarify. Write this property down. Identity property of addition. For this one, just skip 2 lines for the definition. And on the 3rd line, write this down. A equals 0 plus A. 7 equals 0 plus 7. Negative 10 plus 0 equals negative 10. And 1,000 plus 0 equals 1,000. Copy those. And I continue on, but that's the property at work. So look at it. As you're writing those down, start thinking of a definition for this property. If you need to get your noodle started, look at the previous definition that we wrote. See if you can do something similar to this one. Talk it over with your neighbor, please. What would be a definition for the identity property of addition? All right, so we got it. Let's see. Who can get us started with a definition for this property? Yes. The identity property of addition is a number added to these here. Sorry, let me rewrite. Added to 0 to get the same number. Let me read it again. The identity property of addition is a number added to 0 to get the same number. Hands if you agree with that definition? Yeah, that's pretty much it. Now, before we move on, last example, because tonight's home plate, they're asking you to use integer tiles. Okay, so for those of you that have never used integer tiles, look up to the screen. Look at this example. Writing utensils down. Look up. Here it goes. It says using integer tiles or algebra tiles. So here we go. What number do I start with first? 1, 2, 3, 4, 5, 6, 7. What's my second number? 1, 2, 3, 4, 5, 6, 7. -7 and +7, these match up. That means this is a 0 pair. That's how you use that. If you want to copy that, that's the last thing you copy. So you can have as reference for tonight's home plate, because tonight's home plate, they're asking you to use integer tiles or algebra tiles. Okay? So, our home plate for tonight was on the screen. It was 4 problems. You should have it by tonight, yes? Make sure you have that ready for tomorrow when I call your name. And we'll stop right there. Have a good one, guys. Enjoy your home plate. Leave your books at home. See you guys tomorrow. Bye.